So good afternoon. My name is Cynthia, and this is my colleague Chris. We're going to go over testing today.
All right, so what are we going to look at today? First, we'll look at Friendly Eats, a restaurant review app built on both Flutter and Firebase. We'll go over how to write unit, widget, and integration tests in Flutter, and how those tests might apply to your app specifically. We'll talk about Test Lab and how we can integrate with Firebase's Test Lab for mobile testing, specifically for Android tests. Finally, we'll go through some GitHub integrations and look at a continuous integration setup for our hypothetical app. All right, so just a quick note about tests. Why do we write them? It's a fair question to ask. Teams that test their code deliver software faster compared to teams that don't. Unit and widget tests enable test-driven development and behavior-driven development for fast iterative loops. Secondarily, we can prevent regressions with automated tests. So tests prevent regressions from coding mistakes or code refactoring. And in open source environments specifically, we gain additional confidence in accepting contributions from outside developers. Last but not least, we get the benefit of improved app architecture. Designing for testability makes code more cohesive, loosely coupled, and modular. And one bonus benefit is that the tests themselves act as documentation because they're a declaration of your intent as a developer on the behavior you expect from your app.
Right, so to illustrate some of our points, we're going to use the Friendly Eats app. This is a really simple restaurant review app that you might have seen before if you've seen some of our previous talks. Basically, in the home page, we have restaurants displayed. These are read from Firestore. And if we click down to a single restaurant card, we can see the specific reviews being displayed. This is built using Fluttered stateless and stateful widgets. And under the hood, we're calling Firestore and authentication services from Firebase.
So let's say our Friendly Eats app is organized roughly into these four regions. We have our UI at the top, written in Flutter widgets. Further down, we have our business logic. Underneath that, we have our Firebase SDK. And finally, at the bottom, we have our Firebase backend, our UI with widget tests and business logic with unit tests. The benefits here are that the unit and widget tests are quick to write and quick to build and execute. Then we might layer on some integration tests like this. For Friendly Eats, we're going to test the integration between our business logic and the Firebase SDK. Integration tests tend to be a little bit slower running, so we'll have fewer in number, but we can still cover our testing units here. Finally, we have end-to-end and UI tests. And of course, these are known to be the fastest, most reliable, least flaky tests that we can possibly write. End-to-end testing performance benefits can be achieved easily with this one weird trick. So sarcasm aside, end-to-end tests tend to be slow running, resource intensive, and flaky. They definitely have their place, but I like to keep them fewer in number.
So we can get down to writing the tests. Thank you. Unit testing, for the most part, is a really common language in any modern day apps. It's mainly used to validate functions that operate behind the scenes. So something like calculations, querying from a database, or simply setting the value of an object. So first, Flutter provides us with a test.dart package. This allows us to set up our testing environments, assert the expected behavior, as well as debug using the stack traces. For external calls, such as querying data from a database or calling an endpoint, we can mock the responses using Mockito, which will essentially test the response of our function. So here, we have a unit test for a method that generates a random review for a restaurant. We have groups of tests, and within a group, you can have multiple tests. This will allow us to test different aspects of our function or component. So the function that we're testing here, which is get random review text, takes in a rating from 1 star to 5 stars, and it outputs a description. So basically, 10 out of 10 would recommend for a 5 star, and something like I would rather eat from the compost for a 1 star. we are expecting that it outputs a text message from our JSON object, which is review text per rating. And Flutter will help us assert that expectation. And while unit tests are good for assessing individual functions, we want to make sure that user interactions are triggering those functions and updating the UI in the ways that we would expect. So we'll use the Flutter test.dart package from Flutter. So anything that pertains to the UI, whether it's with UI display or user interaction, these can be tested. We can verify that the app is displaying the correct widgets, simulate any user interaction that inside the widget, and then validate those changes. So recall the filter bar at the top of our app, which is default sorted by rating. We want to ensure that the filter's default state is what we expect, and that by selecting review in the dropdown, it'll display changes to review. So kind of like unit tests, we have the test widget function from Flutter, and it introduces a tester. So using Flutter's pump widget function, this will help us render the UI of a given widget. In this case, it's the filter modal. Since the app is by default sorted by rating, we expect to find exactly one widget that displays the text rating. If we find 3, there's a problem. If the test hits these next lines, that means the tester successfully found the modal with the rating. That means that we can have our tester tap on the dropdown, which will reveal a selection of sort and rating. We want to perform the action using the pump and settle function. So cool. So we need to look for that review component that says the dropdown from the dropdown selection. Then we'll have the tester perform another tap. And after these user interactions, the UI should now display by number of reviews. So if we find the widget that displays the text, that means we asserted and validated our widget. All of the tests that we've done so far are pretty much contained within our own app, and they don't depend on any external responses. Mocking libraries such as Mockito help us simulate external responses. It helps us define response, for example, an external API or a function which takes in a function and parameter, and then when we test a function, making those external requests, it receives the expected response. So Firestore has a fake package which can be passed down to our widgets, and when we try to perform CRUD responses or CRUD requests, it'll simulate as if it was a real Firestore instance. So the meat of it, integration testing. We're going to use the Firestore emulators. This will allow us to run our tests on an emulator suite, which is essentially a local Firestore instance. We're going to test the app as a single entity. With Firebase, we have either the choice of using what we mentioned, the fakes library, or the local emulator suites. With unit and widget tests, we relied on Flutter's built-in libraries, and we're going to do the same thing for integration tests. So we first want to set up test findings. When we initialize a listener, this will tell us when the tests finish. And then, similar to the main application, we're going to initialize a Firebase app based on the current platform, something like Chrome, Mac OS, or Android. And then we're going to connect to local emulators in the ports that the emulators live in. So similar to widget tests, we're going to take the entire app as a widget. So we're looking for elements here that we can interact with. So first of all, we want to find the default text for our button. In this case, we're looking at an empty restaurant page, so there should be no restaurants available. And the default text is no restaurants available. We're expecting to find the text for add some button, and we're also expecting to find exactly one widget that does that. We're going to have the tester tap on that button, and now this will generate random restaurants to the that will be written to the Firestore and then being read. So that now it should display restaurant cards in our app. So we look for those. And now to run our tests. So first, we're going to import and add an integration driver from Flutter, and we're going to save the file. In the command line, we're going to point the driver to the file that we just saved and the target to our integration test file. And then the test platform is going to be where we're testing it. So Chrome, Mac OS, Android. And cool. And that's our integration test running.
Beautiful. So the final pillar of our testing story is end-to-end and UI testing. When I say UI testing here, I'm referring to the larger black box testing rather than the Flutter's widget testing specifically. So common testing frameworks exist, like Android's Espresso and iOS's Earl Grey frameworks. But what does Flutter provide in this area? Flutter driver tests can be used to write both integration and end-to-end tests, and they are the recommended way to write your end-to-end tests unless you have specific Android native or iOS native code that needs to be covered. In the case of Espresso, Flutter offers an Espresso test library released in 2019. So once we have our mobile tests set up, we can look at running them in Firebase's test lab. Firebase's test lab is a Firebase service that uses real devices running in a Google data center to test your application. For Android specifically, we can use virtual devices to lower the cost. Test lab allows you to select a device model, OS version, and some other parameters in order to get a better horizontal service for your testing. For example, Firebase recently announced that the Pixel Fold is available to test on Test Lab. So if you don't have a physical Pixel Fold device, you can use Test Lab to get your test coverage. So Test Lab testing comes in two flavors, robo tests and instrumentation tests. Robo tests are automatic tests that are run in Test Lab that don't require you to specify a test script. You just upload your app and Firebase Test Lab will do the rest. Instrumentation tests are where you run your Espresso or integration tests written in Flutter driver in Test Lab. So you get to specify the behavior of the test. Additionally, we have the distinction between hermetic and end-to-end testing. So if we use a mock or a fake SDK layer, as Cynthia described earlier, we get a self-contained integration test with the benefits you might expect, such as faster running time and more reliability. However, if we use real data with a real Firebase test project, we get de facto end-to-end tests with the caveats that you might expect, such as we need to make sure these tests can all run in parallel, and we'll have to tolerate additional flakes and things like this that might occur. So what is the cost of Test Lab? So Firebase offers 15 Test Lab runs per day for free, and then additional runs will be 2 cents per virtual device and 10 cents on a physical device. This isn't generally a huge cost, but may become costly if you're running many model version locale variants, or if you have a busy repo that's triggering these tests often. Now, if we want to integrate with Test Lab, there are 3 ways to do it, and which one to use depends on your app and your specific needs. First, we can go to the Firebase console directly and upload our APK and select device parameters and run the tests. The benefit of this is that it's easy to do and feedback is quick. After the test runs, we can view screenshots of the test execution and check logs or performance and timing metrics. The second integration method is via the gcloud command line interface, the CLI. In your own terminal, you can use a CLI to start Test Lab tests. The benefit here is scriptability, and it uses your own gcloud login credentials to run the test. One caveat here, though, is that because it's using your own gcloud CLI credentials, it's not appropriate to use on shared machines, devices. And there's ways we can use service accounts to get around that restriction. The third integration method that we'll take a look at in a minute is via GitHub action, where we can trigger a Test Lab from a pull request in GitHub. So speaking of GitHub, our Friendly Eats app source code is stored in a GitHub repo. So this makes GitHub Actions a perfect solution to run some tests on an event, such as a pull request or a new branch being created. For that, we'll use GitHub workflow files written in YAML. So this is an example of a GitHub Action job, and it's going to run our Friendly Eats unit tests. Going top to bottom, we can see The test runs on Ubuntu latest. It has a timeout of 5 minutes, and there's 3 steps we're going to perform here. First, we're going to check out the latest code version. Second, we're going to install Flutter with the subaceto Flutter action. And finally, we're going to run our test with the Flutter test command. Next, this is our second GitHub job and the third TestLab integration method we're going to look at today. Here we're going to make use of a GitHub action in the Firebase extended repository to upload our Android APK to TestLab. This is a convenient way to integrate with TestLab and uses the G-Cloud CLI under the hood. One important thing to note here is that in order for the GitHub action to have access to our TestLab project, I created a service account and provided it permissions in the Firebase console. Once we have a service account, we can store the credentials inside a GitHub secret and access it in the workflow file like so. And I've included a link to the service account details and some documentation at the end of this talk, so you can learn more about getting service accounts set up for this purpose. So now that we have our tests wired up, here's a screenshot of our GitHub pull request on our repo that triggered our unit tests and TestLab actions. One additional comment here that I'll point out is that in order for the failing tests to block merges in your repo, you're going to want to enable GitHub branch protections. And then the branch protections can only be bypassed by specific users such as admins or users you select.
Cool, thank you. So to recap, we built unit widget integration tests to validate our app. We've integrated it with TestLab as well and for mobile devices, and we made sure that every time a change is made on GitHub, tests are run to detect and report any breakages. So all of the code that we have on the slides today are available in the Flutter Quick Start repository. So thank you all, and good luck testing.